Hi, 7th grade. Welcome to lesson 7-3. By the end of the lesson, I want you to be able to say, I can determine the experimental probability of an event. Let's solve and discuss it. Kevin is awarded a penalty shot. He will either score a goal or not score a goal. Are both outcomes equally likely? Explain. What might affect the outcome? Okay, so scoring the goal, there's a couple of things that depend on scoring, if he can score the goal. First thing that it can depend on is is his name Kevin? Yeah, Kevin's skill level. The other thing it would depend on is the goalie and his skill level. Because even if Kevin's a super good hockey player, the goalie could be very good and block his shot. So it is not an equal chance that he scores a goal or doesn't score a goal because there are other factors involved. Let's focus on math practices. Lowell's senior high school hockey team won 12, lost 5, and tied in 3 of their 20 games this season. Which outcome is most likely for the team's next game? Explain your reasoning. So they won 12 out of 20, and 12 out of 20 reduces to 6 over 10 or 3 over 5, which is likely. It is 60%. They lost 5 out of 20, which is, let me write this down, they lost 5 out of 20, which is the same thing as 25%, which is unlikely. And they tied 3 out of 20, which is the same thing as 15%, which is also unlikely. So it is unlikely that they will lose or tie. It is most likely for them to win based off of their previous encounters. Example number 1. Compare theoretical and experimental probability. Remember, theoretical probability is what we did last time. That's what should happen. Now, experimental probability is what actually does happen when we try it. So Talia and Yoshi plan for 1 out of 8, or 12.5% of the players winning a prize. During the school fair, they kept track of the numbers of total players and winners and recorded the data in the table below. How does their actual number of winners compare to the expected number of winners? So between 10 and noon, there was 213 total players and 22 won. Between noon and 2, there were 262 total players and 36 won. So the total time, there were 475 players and 58 won. So determine the relative frequency of winners during this time period. The relative frequency is the ratio of the number of times an event occurs to the total number of trials. So you're finding the percent that it happens. So 10.3% of people won in the morning, 13.7% of people won in the afternoon, and a total of 12.2% of people won. 12.2%, isn't that very close to the expected percent that they wanted to win? So the relative frequency of event can also be called the experimental probability. Compare the experimental probability based on the data to the theoretical probability of winning the game. So theoretically, you would win 12.5%. Experimentally, they won 12.2%. So in the previous lesson, Talia and Yoshi expected about 63 winners for 500 players based on the theoretical probability. Based on this data, there were actually 58 winners out of 475 players. The experimental probability is slightly lower than the theoretical probability of winning this game. There were slightly fewer winners than expected. Let's try it. During the second day of the school fair, Talia and Yoshi recorded 43 winners out of a total of 324 players. How does the actual number of winners compare to the expected number of winners? So our experimental probability was 43 out of 324. So I want to find that percentage. Remember, we can set up a proportion, or you can do 43 divided by 324 and multiply by 100. And that gives us 13.3%. So the experimental probability is more than the theoretical probability, meaning there were more winners than expected. Will experimental probability always be close to theoretical probability? Explain. Not always. It depends on what else might affect the outcomes. Example number 2. Use probability to make predictions. Joaquin also kept track of players and winners for his game during the fair. Based on the results shown in the table, how many winners should he expect if 300 people play this game? Well, use proportional reasoning to predict the number of likely winners, W, based on the experimental probability. So out of 416 total people, 71 won. So we can make this a fraction and a decimal. Made it into a fraction over here and tried to set up a proportion to find out, based off of this probability, how many people would win out of 300. So then we can cross multiply, and we're going to have to do 71 times 300 to give us 21,300. And 416 times W is 416W. Divide both sides by 416. That cancels out, and W equals about 51.2. So he should expect about 51 winners, because remember, we can't have 0.2 of a person. Example 3. Explain differences between theoretical and experimental probability. Amir and Marvin each flip a coin 50 times and record the result of each flip. The tables show their results. Based on the theoretical probability, what are the expected results of 50 coin flips? There are 2 possible outcomes, heads or tails, and both outcomes are equally likely. For each coin flip, the probability of landing heads up or tails up is 1 out of 2, or 1/2. So after 50 flips, the results should be about 25 heads, 25 tails. That's the theoretical probability, what should happen. Why might the results be different from the expected results on the theoretical probability? Theoretical probability can be used to estimate results, but it does not guarantee results. The more times they flip their coins, the more likely that their result will be closer to the theoretical probability. Amir and Marvin continue until they each flip a coin 200 times. How do you expect Amir's results and Marvin's results to compare? How will their results compare with their expected results based on theoretical probability? Well, the more flips they do, the closer they will get to equally likely. In this case, it would be heads. The theoretical for heads would be 100, and the theoretical for tails would be 100, because it's out of a total of 200 flips. Key concept. Relative frequency or experimental probability is based on the actual results of an experiment, while theoretical probability is based on calculated results from the knowledge of the possible outcomes. Experimental probability and theoretical probability may be close, but they are rarely exactly the same. The experimental probability is the number of times an event occurs divided by the total number of times the experiment is carried out. This value changes each time an experiment is carried out. The experimental probability tends to get closer to the theoretical probability of an experiment as more trials are conducted. Okay, 7th grade, let's say it. I can determine the experimental probability of an event. Have a great day.